Now I'm gonna see if I can turn off this damn high pitch sound.
When do you think it can start?
Oh, probably 4 minutes, 5 minutes.
Should I go ahead and set up a laptop then?
Sure, if you want to.
Center rail, right, to the left.
Girl.
5 more steps to the place where we're gonna sit. One more.
This one?
Yep.
Unplug something, and the high pitch sound has gone away.
Oh, no.
No, that's perfect. I do not love the high pitch sound. Yeah, if you want to plug in, I can make sure everything's coming through good on the HDMI if you want to.
Oh, okay.
But up to you. I mean, I think we should be okay.
I can do that.
No, it's the height. Is this okay?
Awesome. Anyway. I think you're okay. There's some sort of a pretzel.
One row ahead. What about here? Think people in the audience. Drinks getting set up at the podium.
I'll take that iPad away when you're actually presenting.
I was just going to put it on the computer for now.
Oh, no, it's fine. Yeah, that thing is, it's an ancient artifact.
Oh.
That iPad, I think, is at least a dozen years old. But,
It's reaching artifact status, isn't it?
I mean, it does what I need it to do for this.
It is remarkable that, I mean, would you really use a computer that's 12 years old?
No.
No, right? There's, yeah.
It's not even mine. It's my wife's, and she has a new one. And so this is like literally
Why
the
can't
San
it
Diego.
do it? It works, right?
Yeah, I'm like,
It doesn't
I'm
give
gonna
me
use this, this is the San Diego Python meeting notes device. Because like all my devices are all used, by the phone taking the video and the laptop is taking the, like getting the screen capture. And so, yeah, I literally charge this thing every month, once a month, because it has lost all of its power by that stuff. Yeah, I mean, that's what they're for.
Apple always gets away.
I'm gonna go yell at people outside and then we'll get started.
And then yell at the clouds.
Anybody else?
So yell at the clouds. It's a meme with from The Simpsons, where and there's an old man who's like, pointing his fist. He's showing his fist to the clouds because he's yelling at it, like he's gonna go fight it or something. And it's like it's the cloud. Why is he gonna go do that? You know. Not that one. This one. Make sure I don't have any messages.
All right. I think we'll get started. I know there's still a couple people outside having the pizza, but so it goes. They'll come in when they come in. Got to get started. Show must go on. So you're in the right place for San Diego Python. Hopefully that's what you're here for. You're not here for something else. I do want to thank Qualcomm for having us. They've been awesome to provide us with the space and everything like that. And the engineering development team, or possibly the team formerly known as engineering development, I don't remember what they call themselves anymore. They've really been very supportive of us, and Urivan and Drew, being our contacts, letting people in at the front door, all that. So awesome. I also want to thank Jeremy, who helps wrangle all the speakers so we have good talks. Also, he's on my oh, hold on, I got to refresh this. This is outdated because I was like, oh, my speaker list. Yeah, Jeremy's on my speaker list. We'll get to that in a second. And lastly, I do want to thank Neo4j. They're the ones who paid for the pizza today. Neo4j provides a graph database that for certain types of operations can be orders of magnitude faster than a relational database. And you can download it and run it yourself or run a managed version in the cloud of your choice. So yeah, Neo4j has been awesome, really supported the meetup for like a long time, actually. Like I think it's got to be about a year now of providing us with pizza, so that's great. A couple other small announcements and we'll dive into speakers. There is a virtual Saturday meetup, meets at 10 a.m. on Saturday. Check the meetup page for info. It meets on Discord. You can get to the Discord from the San Diego Python website, which is sandiegopython.org. If you Google San Diego Python or use the search engine of your choice, you will find it. Or you can just type in sandiegopython.org. That will also get you there. It's easy to remember relatively, but sometimes people put them in the wrong order. Python San Diego won't get you there. If you do ever want to help out with the site, sandiegopython.org, it's all hosted on GitHub, and there's people on the Discord who are happy to help you if you want to add a feature or something. That person who's happy to help you on the Discord is usually me, but could be somebody else. You never know. We have a YouTube channel. It's also linked from the website, sandiegopython.org. It's youtube.com/sandiegopython. The meetups are streamed there, so if you ever miss a meetup or you're like, oh, I remember that talk from 4 months ago, you can go back to the YouTube and check the specific talk. That is actually what I use it for more than anything else. The Discord is linked from there. There's a jobs channel in the Discord. I should mention that because there's like 20 people in the room right now. Maybe there'll be 25 after the stragglers come in. But if you go onto the jobs channel in the Discord, like hundreds of people are looking in there, although there aren't hundreds of postings every month in there or anything like that. It's pretty low volume, so you're not going to get overwhelmed with spam or something like that. It's a good channel, local jobs, good stuff. And if your company's hiring, it's a good place to post your local job because, again, there's 20 people in this room, but over the course of a month, a couple hundred people will see the job posting. So, yeah. I want to highlight a couple upcoming Python events. North Bay Python is this weekend, April 26th, 27th. It's in Petaluma. NorthBayPython.org is the website. There will be a couple people from San Diego Python there, and also a couple folks from San Diego Python are going to be speakers there. In fact, I think Trey, last month when I was away, Trey gave a preview talk of his North Bay Python talk. So since I missed it, and it wasn't recorded because Trey asked for it to not be recorded because it was a preview of the talk he's given this weekend, I'll have to check it out. Usually the videos from those kinds of conferences, they come up like a couple days after the conference on pyvideo.org. Where's the videos coming up? The North Bay Python. It's in Petaluma in north, so that's like on north of San Francisco. So like if you cross the Golden Gate Bridge, you'll get there. Yeah, it's far. I mean, you have to take a flight. You have to take a flight, but it's not in San Francisco, so it is quite affordable. It's affordable by comparison. Is kind of the real answer. Yeah, I think it's in a converted like movie theater. So yeah, but it's kind of like a lot of people from San Diego Python go to this one because it's relatively close, it's affordable, you can drive if you want to, that kind of stuff. And PyCon US is coming up. It's next month. It'll be before the next month's meetup. So, you know, next month we'll be like, hey, who went to PyCon and wants to talk about it? But that's May 14th to 22nd. Some of that is tutorials and sprints, but I think the core part of the conference is just 3 days. It's in, I want to say Pittsburgh this year again. Is that right? I don't know. I think it's in Pittsburgh. My notes should say that, but they don't. And I wrote them, so that's on me. But you can look it up. us.pycon.org will get you to the right website. And so all the info will be there, and all the videos from the conference will be up probably a week after the conference. Sometimes at a big conference, it takes a little bit longer because they like to master the videos and make them real nice. And lastly, and the most important announcement of the entire meetup, you can become a speaker at the meetup. Jeremy and I are really focused on lining up speakers because when we don't get enough speakers, Jeremy or I become the speaker of last resort, as Jeremy is today. I feel sorry for you a little bit, but you'll be okay. But anyway, please, please, please sign up to become a speaker. You don't have to sign up for the very next meetup. You can be like, I'm going to give a talk in 2 months. You know, and don't feel like you don't have the skills necessary to become a speaker. You do. You know, we are always looking for talks of all skill levels, whether it's some advanced talk, whether it's some beginner level talk. Both of these sound great. You can do it. We've had a 100% survival rate. All of our speakers have survived. So, you know, give a talk. And you can sign, the link to sign up for a talk is on sandiegopython.org. So, yep, awesome. That's all for my announcements. Our first speaker is Drake. Drake Redwind is going to talk to us about LEGB, which I almost pronounced LEGBI, but I did not because Drake told me what it was pronounced before. So I'll let you take it over, Drake.
Thank you.
Yeah. And then, yeah.
So this is going to pretty much prove that you don't need talking skills to do this. Because I was challenged to do a talk. Because usually I do a Google slide and it's all nice and fancy and there's arrows and a lot of information in a short amount of time, but I was challenged to do it without a script, which is why I am rambling on right now, trying to, okay, I'm just gonna get into it. So I just made this one little thing. So on top of the challenge of doing it live, I'm also doing something that a couple of the people said couldn't be done. So this is my LEGB3. I had, the way that I do things is I just make a project and then I keep numbering it. As you can see here, I have delete stuff, 1, 2, 2, 2, 3, 2, 4, 2. But yeah. So what I have here is just a very simple script. I declare dog name. The dog's age is 1. Every time I call the name dog definition or module or whatever you call this, it's going to say Ace. I can name him whatever I choose. And then I'm going to print out dog's name changed to this. I'm just doing that for debugging purposes. so that I know what my script's doing. If you don't know what your script is doing, it's usually best to just make it tell you what it's doing. Dog grow usually just increases his age by 1 and then declares what his age will be after that. And then print dog data. And so that should print out dog name. And now that I'm looking at it, it's going to also run the script or module, keep forgetting what it's called, dog grow. And now that I'm looking at it, instead of just printing what his age is, it's going to age him up by 1 and then say what his age is. So that's already not very accurate. And as you can see, there's nothing at the bottom. This is where you would usually run everything. And that's because I'm going to be using LEGB3 as a tool for LEGB4. So in LEGB4, or in 4, we're going to import 3. And then this is the part that a couple of people said couldn't be done. So by declaring, or by referencing number 3, I can take the name dog name, or I can take the module dog name and rename them to Ace. But I guess I was playing with the code. I haven't seen this code in about 2 months. So we're just going to make that Fido again. So this is going to rename it to Ace. Actually, before we start, let me just run this one so that we can see what this one will do. Right, it does nothing because there's nothing for it to do. I didn't call any of the modules and I only declared things. So the dog's name is Ace, LEGB3 print dog name. That's just going to take whatever the dog name of the dog in number 3 is and print it out. And then I'm also saying to print out the dog name using the 3 script. And then I'm going to age him up twice and then tell the computer or the script 3 that his age is just going to be 5. And then we're going to try and figure out if his age actually goes to 5. So if you run this, no interpreter. Let's try this one. Run. All right, so as you can see, it worked. The dog's age was up to 5, and now he's 6 years old. And let me find what his name is. His name is Ace, which means this code at the top here worked correctly. So I was able to change his name before the script 3 was able to print it out. And that's pretty much the end of my talk. All right, any questions? And that means I did a good enough job explaining it. Thank you for your time.
Thanks, Drake.
Welcome, always welcome.
All right, no, I have my thing backwards. All right, thanks to Drake. Jeremy, my co-organizer, Jeremy Langley, is going to be our next speaker. He's going to talk to us about Instructor on instructing instructors with Pydantic, I assume.
Mm-hmm.
All right, Pydantic'ly.
A couple things about how I'm using this. Let's see. Let's see. There's a typical workflow whenever dealing with LLMs. Huh? Oh, hello. Testing 1, 2, 3, 4.
I think you were just far away.
Oh, okay. Let's see. Whenever people want to use LLMs, they typically want to hand control over to the user, or hand the user over to the LLM and continue the entire interaction apart from, let's say, from whatever internal systems that you have. So you're not looking to bring back any information from LLMs. So Instructor helps you to use a function or develop a function that has an LLM and then bring that back, let's see, and use that information inside your program. Now, if the demo gods will let me display this properly. Let's see. Displays. Reset refresh rate. Advanced. That there. Oh, sorry. This maybe it's based off of HDMI.
Yeah. Yeah.
Aha. I do see this. Yeah. And or something like that.
Yeah, you don't want this unless you cannot use HDMI.
Yep. Okay. Arrange. Done. Okay.
I would unplug it and plug it back in
So
that it makes sure. Oh, you think it's stretched? Maybe.
no. Let's see. This. Okay. Display is not Discord.
Mhm.
So
Hopefully the magic just happens this time. Are Macs supposed to just work?
that was the selling point.
That was the selling point. What do we do? Maybe we'll fire up displays again and we'll take a quick look.
Display. That's
Should be under system preference, system
Displays.
settings. Okay.
range.
I don't think that's what you want. is it?
No. Extended main display.
I think that did anything.
Well,
Would you go to what is it? System preferences or something?
Is it Windows or Mac?
It's a Mac.
Mac. Let's see. This. That will do it.
I think we did something wrong in those preferences.
Okay. This.
Is there a search function?
Yeah, just do
Screenshot?
just do system preferences. Fire up system preferences.
This is it.
This is it. Did it change what it looks like? Okay. Well, that's interesting. Okay. So we don't care about any of this.
The microphone did seem to stop working around the same time. So
Huh. Oh, I wonder if something went off with the projector. Projector does not hook on. There we go.
Okay. That's coming.
Audio should be hopefully on. Power is on that.
testing. Audio's on.
Hey. Magic. Maybe. Okay, this is coming up because I see you here, so it should be up there as soon as the projector warms up. There we go. All right. Problem with the.
Oh, okay.
That was the presentation.
Let's see. Let's see. Sorry about that. Let's see. I need to have the displays mirrored. And resets. Okay. I got it. No, let's see. You could see it. I get a background. So now, mirror. There. Now I get to see it too. Two-player mode. All right. So, what do you think? Let's see. We've got. All right. So back to rewind, just in case for the people at home. Let's see. The way that people generally use LLMs is they hand the customer off to the LLM and then they never see it again. So what we're trying to do is build in a process by which you can ask the LLM about something, maybe in a customer interaction, but be able to gain back control, specifically while gaining, getting back something from the LLM in a way that you can use it. And for the, let's see, there's been some commercial vendors who have been able to put in JSON responses. And so they're usually very expensive. And I'm going to show you how to do it locally. So this is using a library called Instructor. So with Instructor, you can take the OpenAI has an API that will allow you to be able to connect to anything. So in this case, we're going to connect to a local LLM. I have a local LLM running in LM Studio. Up at the top, it's Llama 4. I've got it serving on port 1234. And you'll notice also my wireless is off. So nothing up my sleeves. And because this is running in a graphical user interface, we're going to be able to see the inference. So I'll explain the 4 sections of this. So Pydantic is types for Python before there was the typing library. So before there were data classes, before there was the typing library, there was Pydantic. And let's see, it's been a long standard. And so I'm going to be developing a couple of classes. Let's say like this is a character. Character from a movie, character from a TV show, where we have a name, an age, and a couple of facts about it. So I'm going to open up a client. Now notice that the base URL is on localhost, port 1234, and I got the base URL information from LM Studio. They have a chat window over here with some code on how to be able to access it. So the API key. Well, if you're not using those, let's say, commercial vendors, then let's see, I've got needs to be here, but it doesn't matter, all in a string. So it does, let's see, you cannot be without an API key, but let's see, once again, you don't need to fill it in with anything. So the mode I set on the client to instructor.mode.json. And what this will be able to say, hey, we want JSON back. So here's where I list out the question. What do I need to be able to ask of the LLM? So in this, I'm not sure exactly why this is so deep. The client.chat.completions.create, but you know, they were Java programmers who came over to Python, I'm assuming. So once again, the model, you can specify the model, but it's running on a server, so you don't really need to specify the model. So I've also got a string that says needs to be there, but doesn't matter. So my messages, I've got a dictionary that says role is a user, and the content is tell me about Homer Simpson. But this is the important part. Outside of the messages, I've got a response underscore model, which is equal to character. And this is that Pydantic base class or base model that I based it off of. So it's going to hand it back in that format. And with wireless turned off, I'm going to run this and take a look at the server, watch the inference in real time, get back an answer, and you'll notice that the answer is in JSON format, and now I can be able to use this in my program. All right, so far, any questions? Wonderful. All right, so you can, yeah.
I've also found that JSON is just the best format to feed data to the LLM. I guess that's the reason you also picked JSON, right?
Yeah, JSON, it used to be XML. I'm not sure if that one's still king. I'll see, but I'm getting a couple of head shakes around. So yeah, they've trained it more on JSON recently because they're knowing that, let's see, people would rather use JSON, smaller format. You don't have things like namespaces in XML. You don't trying to do security and CSS and data transfer all in one language. Just saying, maybe JSON's easier. Yeah.
Can you also use YAML with this?
Can I use YAML with this? I don't see why not, but you'd have to build it into Instructor to do it. So you see this instructor.mode.json. There's a couple of modes that it understands. JSON is one of them. I don't see a problem with extending that to YAML. We'll get into something in just a moment about templating your questions. So,
Is there a chance that it fails at fitting the template?
yes, yes, there's a chance it fails. Let's see. There's a chance. I haven't hit very many. Let's see. I would definitely use this in a try except block. Let's see. The Pydantic has some ways to be able to find out, do some validation before, validation after, to make sure the LLM is returning responses that make sense. And we'll see that in just a moment. All right. So we can change the name. Let's say Alfred some very long last name that was just keyboard typing. And I'm going to rerun that. Tell me about Alfred. I just drum my fingers on the keyboard for his last name. And our inference is running. All right. So the function is, let's see, not returned objects in the JSON format. So this is an example of one of the errors that it throws. So, there was an instructor retry exception. So it tried to do it once, and if it doesn't come back with the right answer, it gives up. But you can also change that. So I'm going to go to a different file. It's the same instruction, but this time we're going to add in two other pieces. Let's see. The messages in the client chat can be formatted like Jinja templates. So it is actually Jinja templates. So if you need to be able to run a for statement in your prompt, then go for it. Let's see. It has that capability. Let's see. It separates concerns, so you can pass in a context dictionary. And let's see, whatever keys that you specify will show up in your template for your content in your messages. And I can change the max retries to be 3, just in case it doesn't work. And I'll just go ahead and rerun this. Or sorry, run the second one, and watch the inference. I'd rather see the inference on the server than try and get it inside my answer on the program and then have it fail. It's just messy. So we get facts about Homer Simpson. He's 40. He's a nuclear safety instructor. He has two daughters, Bart and Lisa. Any problems? Let's see. And his favorite food is donuts. So, trust but verify a lot. Anyway, so this is Llama 4. Let's see. So it's not answering that way all the time. I've rerun this many times. It's been able to answer questions about popular characters very often well. So. The Harry Potter series and Homer, the Simpsons characters, it's been able to do well. Okay, so this is the only one that I haven't run all the way through, and it's because of the model that I'm using. The reason I'm switching out the model is because we are going to be using tools. And the way to do that is to change the client. You can change the mode to instructor.mode.parallel_tools. We're no longer in the JSON scenario anymore. So I've got two different pedantic base models. One of them is called weather, and another one's called Google search. Weather, I just need the locations and the units. And a possible Google search. Let's see, I'll get back to the Google search in just a moment. So in this, I can, let's see, what is the weather in Toronto and Dallas, and who won the Super Bowl? And the response model can be an iterable of one of two let's say, base models. So you're either going to use weather or you're going to use the Google search. And so you can pass both of those response models in. Let's see. Documentation says this. I've actually tried this out, and let's see, on Anthropic's models, and let's see, they work really well. Yeah.
What do you mean by response model?
The response model, sorry, up here we have a couple of the pedantic base models, and so I've made a weather-based class, and it's either going to return the weather or it's going to return a Google search. So it's going to return these types of data. So
it's like a tool.
Yeah, it treats that like a tool. So, all right. One thing with the Google search is, let's see, it's the Instructor has an LLM validator. This is a game changer. I want LLM validation on, let's say, my models. So sometimes you can say things like, I want to return a phone number, or I want to return the weather, and you can easily verify whether or not it gave you the right response. However, if maybe it's complicated, like this one, in a Google search, don't say objectionable things. That's really hard. So the LLM validator can be used in the Pedantic's validation called before validator. So before it sends off this to the LLM, it makes sure that it's not objectionable, which is itself another call to the LLM to check whether or not. So it's two calls to the LLM to be able to get a Google search. Anyway, but that's a fancy feature. Love it. It makes sure that the information that I need is there before I try to go and verify this. Things like I would like to, or how I use this. I'm using this on a website called conceptual.fyi. The idea, it's our educational website. It breaks up courses into individual concepts. And I want to make sure the concepts don't have ads. So sometimes it's YouTube transcripts. I download the transcript. I make sure to pull out the content before, let's see, the content of the ad before I do any evaluation of whether or not it's teaching a concept. So this is a good use for the LLM validation. All right, any questions? Yeah.
So if you make one of your models like an error handling model class, can you use the same way that you passed in the iterable and then union the two? Yeah.
Yeah.
Make one of those an error handling class and then successfully, I don't know, get a rather than needing to wrap up in the score and catch, yeah, make an error handling class and then maybe better demonstration on the Homer Simpson.
Oh, yeah. Error handling base model. So message string, that's is what he's proposing. So yes, let's see, we can, the error handling will pass it in. Now this assumes that the error handling will be handled by the LLM. So this is not, or let's see, it's not going to be handled in Instructor. You're assuming that the, let's see, as part of your prompt, you say, what is the weather in Toronto and Dallas, and who won the Super Bowl? And if you're not able to answer any of these, give a reason why. You know, then the LLM is able to come back with one of these three options. It's either a weather, a Google search or one of these error handling things. So if the LLM doesn't know, sure, let's see, but it's not going to be handled by, or if it breaks, if the LLM itself breaks, you need to have it handled by Instructor.
You mean if you get like a 500 response code from the server?
Yeah, that's not going to be handled here. So
And at the same time, I think it's going to just take tokens from the LLM itself, having to decide to use a particular tool versus the other, versus just giving it to your instructor. I did, for the question that he had, GUI actually uses Jamal in order to feed its agentic system all the instructions for each one of the AI agents. So that's where I know that JSON is not the primary form in which you input information, in which you use Jamal for. In fact, GUI is more efficient in using Jamal for its agentic system.
neat.
Do you have any interest in trying to see if the Homer Simpson keyboard smash, if it will try and give an error handling response? Would you like to just see if it
Live code in a demo going badly?
Just change the content portion to what, like, who is and.
I'm up for it.
Curious.
All right,
So
so
you're right, it is borrowing from the token.
Yeah, so that's what
You
that
don't
is.
all right, so I'm just going to.
And it has expression as to which tool it's going to use in order to solve whatever issue it has.
And error handling or yeah, character. Thank you. Error pipe error handling. And for some reason this is not.
You've got a typo.
There it is. Handing. Oh, handle.
There's a typo in the one below, though.
All right. So iterable. All right, so I changed the content. Tell me about Alfred, gobbledygook, or if you don't know, give an error. So, huh?
Yeah, give it like a
Response
response branch.
branch?
Like if this is wrong, then tell me there's an error message. So that's
Okay.
Should you do that?
Yeah.
Note that if there's an error to say something about that.
Well,
or maybe instead of prompt, maybe that should, or maybe instead of content, maybe that should be prompt.
That's just, I think it's good. Let's try it.
Fire it.
okay. Yeah, union type in there.
Yeah, usually when I had to rail guard my agents, I had to be more specific as to how to handle errors.
Okay. Let's see. I'm going to have to look this one up. So this was not something that I was expecting off the top. Yeah. Another question.
So the Bart and Lisa being daughters is interesting to me. I'm wondering if you can structure your model to also assign it a confidence factor with the facts that it provides.
Inside the list. All right, so we've got a list of strings, and each one of those strings can be, we need to change the different types. Let's see, but I'm seeing that I'm going to run out of time very shortly, so
I'll do it on
yeah, let's see. Let's talk about this afterwards, and let's see, come and talk with me afterwards. We can try and either fix or, let's see, have some fun with this. Anyway. I'm going to be up here all night. Anyway, thank you very much.
Thanks, Jeremy. Hobson, you're up next. Where'd you go? Oh, you're right there. All right. Hobson Lane is going to talk to us about Knowt. Is that like Knowt? Do you pronounce it?
Yeah, I kind of evolved the presentation notes, so
Oh, okay, I'm just going to let Hobson present.
So Knowt is a project that
You want that thing?
Ethan worked on for us back in the,
You just need that if you.
I don't have HDMI.
Okay, then you can. It can plug into this, and that's what you want to do. So let's unplug these, and this should just work. It showed up thing. It said source HDMI, so I think it's thinking about it. Oh, I see. Yeah, it's extended to the other screen. So.
Okay, great. I just got to move my stuff over.
All right.
Thank you.
Yep.
So, from Hobson Lane, I'm going to talk a little bit about a project I've been working on, a couple projects. One of them was Knowt, like that David just mentioned. Ethan built a system for RAG back before RAG was huge, and so it's a command line app where you can manage your own data and search your own data, like desktop search was 15 years ago before Google decided they'd rather advertise to you. And then another project, Medins by Job Crowder, a former San Diego resident. He's given me a little bit of funding to help him incorporate the chatbot architectures we have in the in natural language processing in action. And he and Alicia Chen are building a chatbot to train therapists for a professor in North Carolina. Taylor Kirk, Jason Odell, I'm going to show his Django app and at the end of the presentation. REIT is a local UCSD project funded by the NSF, so I'm also involved in that. So the talk will be about an assignment for students in my classes in Python class at Mesa College, and how I'm teaching them to plan a program and to also plan dialogue for a chatbot, and then implement that plan, and then show how that's very similar to decision trees and deep learning and large language models. But I'm going to show you how to get serious about reliability that you can't, for things that you can't depend on LLMs for. That'll be the hybrid architecture, and Convo Meld is another project where if anyone commits to contributing an hour or so of pull request work to that, I'll give you a free book tonight, and signed by the author, by one of the authors. And Indica is the Medins project's web app. And IPython aliases in case you want some extra tips while I'm doing a quick demo if we have time. So your assignment is to use only the keywords if and print and input to build a chatbot or a text adventure. Bonus, if you want to use, define a function and use in and stir and some of the lower and upper methods. So these are for beginning programmers. So what are text adventures? Well, you could building there are a lot of Gen X people like me, very famous developers who got their start in building text adventures. Building character sheets, die rollers, Dungeon Masters. Oregon Trail was a famous text adventure sort of program. Colossal Cave Adventure was probably the most famous and first. Rogue was a semi-ASCII art text adventure. For the assignment, the students this is an example that one of the students came up with. I asked them to draw the decision tree before they implement it so that they can get in the habit of not just vibe coding and actually having a plan. And you can see that it will help also in actually bringing some reason to what you want a bot to accomplish. So this is an example of how you might implement a chatbot architecture like that, just with a couple nested if-else loops. Really simple stuff. I didn't really want them to do much. And of course, you can make it more robust to natural language phrasings by using things like in, checking if the user's response is in the possible set of options, or the string that is one of the options. You can strip it, you can make it case insensitive, and so on. Just tricks for, but of course, that's not really extracting the meaning. You're still just extracting the spelling of what the user is saying. And so you need something a little more powerful, like real natural language processing. To test them, I used, you can just open loop test them by printing to a pipe and then having those commands go into the game. Open loop, so it'll probably trigger mostly the else branches in their code, but at least it forces it to exercise a few of the branches in the code. You can do it, another great tool if you actually want to automate bots talking to each other, or automating a gameplay bot like I have for my class in order to test out all of these games that students are creating. You can use this project called P-Expect. It's an asynchronous library, so that you can send those as if you're typing at the keyboard, and you can use regular expressions to match what's coming in, and use those and use that text that you matched on to make a decision on how you play. And if you can also do this you can plug in an LLM, obviously, instead of a regular expression. You can just take the text like I have done here. You put a dot star as your pattern that you're looking for, and so then you take that text, send it off to an LLM, and ask and see what its response is, and then pipe that response into your bot. So you can have bots talk to bots. You can have bots talk to your command line programs. You can do all sorts of cool stuff with P-Expect. So I'm not a big fan of using LLMs to grade students' homeworks. I didn't show the other. Darn. I did use Pylent to show them how they can improve the style of their code and readability and such. But once you get down to brass tacks, I got to use the REPL approach. So I go through their code, I read it first, then of course I evaluate it, I actually run it, and then normally you would print, but I just play their game. So now once you want to get serious about chatbots and you're not just playing games, back in the old days, 80s and 90s, you would have phone trees that were built this way. Autocomplete is built this way, with just rule-based chatbots essentially. Therapy bots, even in the early days, in the 60s, late 60s, early 70s, was the first instance of a chatbot, and its first goal was therapy. And it used the same therapy technique that they're using now with an LLM. And the LLM is doing poorly at it, much more poorly than Eliza did. And that's why they brought me in. ChatOps is another common application of chatbots. Search, obviously. So Google search used to use a chatbot, a rule-based chatbot, to extract the actual entity that you were interested in, the definition or the person's birthday or whatever you were looking for, and put it right up top until they decided they needed to make money off of your eyeballs in other ways. RAG is, like I talked about, this Knowt project. If you can look that up on GitLab, and you'll find that work by Ethan and I to build, use LLMs to summarize your search results for your own documents, and also do semantic search. But then you can go full Monty, a naked LLM like Grok or ChatGPT, and and just throw and not put any rules in the system at all. Really bad idea. However, it's catching. So even Sam Altman says, we're taking the gloves off. No more rules. Bomb making is fine. Just go for it. So they're going the way of Grok and anyway. CLI assistants like Shy. It's another good pipey Shy Python or Shy Shell. It's a really cool LLM that suggests you can ask it questions like, how do I list all the largest files in a directory? And it'll give you the actual command line in Bash, and you can execute it or not. So it's really good to have a rule-based engine or a reasoning engine in between the LLM and the actual keyboard. You want to confirm that it's not going to erase your hard drive. Vibe coding assistants like Copilot, Cursor, Aider, be careful. You may be training your brain not to be able to write code and reason about code, because it's not reasoning about code at all. It's not reasoning about anything real. It's only reasoning about tokens and token statistics. That's all it knows. I'll explain a little bit more about why I'm so confident in that and why very few people are besides me, except the DARE group over in Arizona. Massive homework crib sheets. That's basically Claude and Gemma, and that's how most of my students are using LLMs, because they can search basically the entire internet of all homework assignments ever read by LLMs or scraped by Google, and produce their answers by interpolating those past answers. Gemma is yeah, exactly. Gemini is also their LLM, so they have two. Gemma is the one for coding, I think. Oh, I see. Thank you. I don't. No worries. So now when are we going to get really serious? So now we're talking about someone's mental health or their physical health. If you're talking about medicine or therapy, you should really have something in between the statistics bullshit engine and an actual diagnosis or dialogue with that patient. Because these patients often are on the edge. They're often a risk for self-harm. And so this is an example conversation between a student therapist in training and an LLM. And the goal was to help the therapist. The therapist didn't do well, and neither did the LLM in this particular dialogue. But anyway, I'll show you how you can turn a script like that automatically into a rule-based engine. Yes, I'm not going to talk about it then. Artificial intelligence is the only there's only one problem with artificial intelligence, AI. It's dumb. It's been trained to not be dumb, but it is. Dumb in the sense it's been trained to speak, and that's one meaning of the word dumb. And the other meaning of the word dumb is not making sense, and that's the crux of the problem. Natural language is ambiguous. Code is not. Data is not. There is no way you can possibly translate a rule, a hard and fast, discrete rule, or piece of logic, or algorithm you've got in your head, or an algorithm that you've got in pseudocode. You cannot translate that into natural language and then expect, which fuzzifies it, adds ambiguity, adds interpretation, adds implementation details that are not in the natural language, but are in the structured data or the programming language that you originally had in your head. And so it's going to fuzzify the algorithm, And then it's going to inaccurately attempt to predict what the natural language, in a natural language sort of way, in a statistical way. It has no grammar of the rules. For instance, the rules of chess are very obvious to a human, can be learned pretty rapidly by a 7-year-old. But an LLM will start to make illegal moves after the 5th move when even the smartest LLM, if you put it up against GNU chess, in the same way that I just showed you with pexpect, that's one of the examples I show, it will fail to even make valid moves because it doesn't have a grammar in its head. It doesn't have a finite state machine. It does not know what a valid move is. It only knows what's statistically likely to follow in a winning game in terms of moves. And it's doing it in a statistical interpolation. It's not doing any kind of reasoning. If you doubt me, Anthropic has done some really good work in this area. Look up on the biology of LLMs. There is 13 different ways it is not reasoning, shown in 13 different papers where they show the actual reasoning that's happening and show how it's the opposite of what it says its reasoning is in a chain of thought that you ask it to output. Well, not opposite, but just orthogonal. It's not reason. What about decision trees and rules? So it's really a pain in the ass to go through and write all those if statements. So is there some way that we can infer it from a bunch of examples? Well, that's what you call a decision tree. That was all the rage back in the 70s, 80s, and 90s for what was called expert systems. And then machine learning came on and overwhelmed the experts who were trying to program those rules and thresholds into an expert system like this. And by doing statistics, doing science, doing data science on the data, not giving it the answer and then asking it to regenerate that answer, but instead creating an abstract representation of the world and then using and predicting whether or not, having it make predictions without it knowing the answer. Doing actual science instead of vibe. Bayesian networks for medicine is a good example of how you do that. So if you haven't looked at the Bayes rule, it's a really eye-opening bit of math. But anyway, I won't go into this you can see that this looks a little bit like a dialogue tree or a decision tree, but it's a graph. It can have loops. It's called a Bayesian belief network or a causal graph or even a knowledge graph. But you can get a lot more accurate results, reliable results out of Bayesian networks. You notice how small that network is? It takes a lot of time to train these and a lot of compute to train these and a lot of data, and comparable to the amount of data it would take to train a deep learning network to do it. But it has about 8 orders of magnitude fewer parameters. You've compressed let's see, the latest models, some of the largest models I've seen lately are half a trillion parameters, 500 billion parameters. And you're looking at, for each of these, you're looking at, on the order of 10 parameters for this Bayesian network for the same problem. So you can see how if you take something that's extremely structured, the logic of the relationship between smoking and dyspnea, bad breathing basically, and tuberculosis and cancer, if you take those relationships, those statistical relationships or those logical relationships or those causal relationships, and you turn them into fuzzy, let's guess what cancer is, let's guess what smoking is, let's guess how a human body works, and put that into a sentence, the word smoking, oh, the patient smokes, and the patient has a tuberculosis test that tested positive. You take this data here that's in quantities that are actually measured in blood tests, and you turn it into natural language, you're just introducing error. There's no way you can avoid not adding error to the decisions that it makes. And this is an explainable network. You can go to the patient, explain to them why you made the diagnosis and why you're asking them to take this risky surgery. With an LLM, you can ask it and it will tell you, but it will not tell you the truth. It will make shit up. The learned decision trees. So that's what we just talked about. You can feed them a bunch of data. They can see where the dividing lines are. And turns out, surprisingly, in machine learning, that if you make those, bag and boost, if you bag your data so that it learns a random subset of your data set and the statistics on it, and do it many, many times. So there's very weak learners, very poor learners, and then have them all vote together, just like the wisdom of the crowds. That turns out to be the winning approach on nearly every Kaggle competition you'll ever do. It's called bagging and boosting, or XGBoost. And it's basically a random forest with a couple other extra twists. It's a bunch of decision trees combined together and averaged. Neuromorphic programming, deep learning, I'm not sure what I wanted to do here. Oh, I just wanted to help you see that analogy between that simple 10 box, 10 edge graph and the actual graph that's being computed when you ask an LLM a question. It's instead of a decision tree, it's more like a root ball. The Book of Why, another great resource if you're actually interested in making repeatable, reliable predictions about the world. So how can we bring in rules and logic to LLMs and natural language? Well, I showed you one way, with the simple if statements in a tree. This is another way called hybrid code networks. This is out of a paper that I just recently discovered. And fortunately, it's very similar to what I published in the book. So you have entity extractors and slot fillers on the left who are actually using natural language processing the way it was intended to actually try to make sense of the words and turn it into structured data. Entities are things or objects that are named within a sentence, and then those relationships between them can be extracted, and then you can actually exercise logic on those things based on algorithms that know what those things can and can't do. This is a similar diagram that put together 4 years ago as we were writing this book. Same basic concept. You're just combining. Let's see if there's anything key here that I should be. You notice there in the middle there's this utterance embedding that contains all the semantic information of the natural language text, and you're putting that into an RNN combined with all that structured data and any tool use you're doing, like writing a linter, running a linter, or running a compiler on your code, etc. And you can also look for the exact spelling of things using a bag of words vector or a TF-IDF vector, so that you can not necessarily, so you can actually have names that are recognized as names rather than as fuzzy matches of vectors that represent those names and in meaning space. Any key things here? No, I don't have time. So Convo Meld is, if it's on GitLab, Tangible AI, community, Convo Meld. There is a package that I've put together that can do a lot of this stuff for you, to help you merge conversation logs. So that conversation log I showed you I'm using it for Joe Crowder and the Medins project to merge those therapy training sessions together to create a bot out of the decisions that were made by a human. so that we can mimic those same decisions in a bot. So, and we can create embeddings so that that fuzzy matching that we're talking about, like lower casing, doing case insensitivity, we can actually make a match on closeness and meaning between what the therapist says to the bot, so that the bot can behave in the way that a human would, which would be logically. So they get worse if the therapist does not use the correct reflective protocol, and instead does what some of these students did unintentionally and made things worse. Okay, I'll go to this website, and so you can see a little bit about what we're talking about. So unfortunately, they were using almost purely LLMs. You're using a full Monty, bare bones LLMs, and these are a bunch of the different prompts that they've come up to get with to prompt the various the clients or the therapists. You can, they don't yet have a way of having conversations with them. So I'm just gonna take my command line interface and turn it into an API so that they can have a conversation with the rule-based bots and the hybrid bots and their LLM bots. And so they can compare them and see which ones the professor likes better. One last quick demo if I have time, if David's okay with that. Here we go. This is going to be tricky. If I can see that far. Darn. I can't switch. Okay, anyway. What was I going to do? Oh, probably don't want to. I've lost my train of thought on even what I want to do here. Yeah, this is not working. Never mind. I need to set up mirroring on my laptop so I don't have to look that far. Any questions? So I was just going to show how you can, some tools I have for taking those dialogues, merging them together, and then showing a diagram, creating a diagram from the graph, from the merged conversation trees, and then and so you can display it and edit it. There's a really cool package called Draw.py.o, which can produce editable PNGs or editable line drawings, SVGs, editable graphics in the Draw.io format, if you're familiar with it, open source JavaScript package that's awesome for creating slides, creating diagrams, creating anything. None of this Acrobat BS for me. Questions? Yes?
For the PyExpect, do you have to tell it every output or every input it's able to give?
Walking over standard in, standard out. That's all it is. You can do it with a pipe, but you can only go one way. At least I hadn't figured out how to make a loop of pipes.
But how does PyExpect know what a valid input would be?
You have to write the program that tells it what it is. That's the crux of this whole entire presentation. You don't get anything for free. Yes, you can ask an LLM, but it's not going to be correct. At least not reliably correct. It might get lucky. It's been trained by a lot of smart people to be really, really good at fooling you into believing that it's correct, but it's not. Yep.
Yeah, I mean, regarding the question of accuracy of I agree. Like, there's so much variability to even answers to specific problems. But even within that variability. I find it so dynamical to be able to use some LLMs
Yeah.
in order to solve problems that I explicitly give up precision for the dynamism of LLMs
Yeah.
in specific scenarios.
Your vibe is very dynamic. I love vibing. You know, going to a rave and vibing, awesome. But
But
But-
it does like a lot of the workloads that I would have to carry out, and I just have to go back and resolve some of the issues. So
Yeah.
it does for me at least increase my productivity to a great extent.
yeah, you're not alone. Everybody believes that. I just don't. I think I need to be productive at the hard things, the things that actually require logic and reasoning, not productive. Well, I don't know. Yeah, people can use it well, and I'm sure it can be used well. I just don't.
We'll get there.
They're going to try to force me to, but I think hopefully I'm too old for them to, too old a dog to learn new tricks. Because the worst thing about it for me is the thought that it's going to change the way that I think. For instance, there's innumerable security vulnerabilities that are injected by LLM code every single day. And it's going into open source projects. These are habits and patterns you're learning. It's just like having, you go to college and you have a professor and you do some pair coding with them, or you have a TA, or you have an assistant, or you have a coworker and you do some pair programming. It's just like that. Would you choose someone who you knew was sleepwalking on the job? They were just vibing. They were just banging some stuff out, and they had a really good generator of a grammar, like a regular expression run in reverse, that would just generate stuff that's syntactically correct, that sort of matches the semantics of what you're asking to do, but they have no logical reason for why it came out that way. They just get lucky. There's just this brilliant it's like 100 brains in one, just vibing. Would you choose that over another human being? Personally, I'd choose another human being. And
the sleepwalking entity is smarter than the fully awakened person. I will pick the fully paralyzed entity.
sure, yeah. Everybody's doing it. You're not alone. Not for me. Because I will start to think like that paralyzed person next to me. When we say it's better, yeah, it could do it faster, for sure. It can burn up the rainforest while it's doing it, but it's not more efficient. It's not more efficient in terms of, it's only more efficient in terms of time, not more efficient in terms of energy, environmental impact, accuracy of code, whatever.
We got one more speaker, so let's.
Oh, sorry.
Let's wrap it up and get to the last speaker, if that's okay.
I could talk forever, so
Yeah.
thank you.
Sorry to cut you off.
Thank you, Hobson. I just wanted to make sure we have time for the last speaker. Fae Gaze is our last speaker. Fae is going to talk to us about locating bacterial, oh boy, this is a big word, flagellar motors and 3D RNA folding with deep learning. All right, Fae, take it away.
Sorry, Hobson, I just wanted to make sure we had time for the last talk.
Oh, thank you. I was going off the rails.
Is this what the paper that you were furiously scrambling about is also about?
Yeah, it's related.
Okay, cool, great. You have a laptop? Okay. If it's okay, yeah. So this should be good, and then I'll have a timer for you, which it's not super strict or anything, but just make sure that I want to try to wrap up on time. Is kind of where I'm at. All right, and hopefully it should just show up. I see that it recognized the source, so it should be coming up here, or possibly on the other window, maybe. It hasn't come up yet. It says it recognizes it, I thought. Isn't that what that says? No signal is what it says,
No, it
actually,
doesn't.
under what I can see. So
So what can I do? It's just
let's try that again. It's a Mac, so it should just work. That's what I was told,
Mac
right?
should work.
It should.
Maybe just connection. Just a second.
Let's see. If this doesn't work, I have another adapter for mics somewhere. We can try this one, but I have to make sure I get this one back because it's mine. All right, let's see if this has any luck.
Did you guys get a pop-up to allow the
Oh,
Yeah,
it,
that
it
was-
just came in. So, okay, it's up on these. So there we go. Okay, we're good.
Yeah.
Take it away.
Hi everyone. Today's presentation is about the Bacterial Flagellar Motor. The purpose of this presentation and this project is related to my initial work about cancer progression and personalized medicine. I noticed that when I was researching about this, that so many people, they're suffering from the antibiotic resistance, especially those that they're going through the chemotherapy and radiation. And this is very life-threatening, the antibiotic resistance. So that's the reason I'm working on that, to help the pharmaceutical industries to create the new antibiotics, to help those individuals with the weakened immune system. So here, the objective is develop the accurate and efficient deep learning model to detect the bacterial flagellar motors. What is the motors? The motors is this part that you see that it's a moving part inside the bacteria. So it's a very tiny section, and it's causing the bacteria to develop and to swim from one section of the cell to another, and this is spreading through the bloodstream in our body. So that's a very important part for the not only for designing the new antibiotics, but also is helping for the nanodrug carriers. It's a robot that can be targeted exactly to the infection part of our cells. So it can fight back or stop the bacteria from progressing. The challenges is that motors inside the bacteria that is causing the bacteria's growth is very, very tiny. It's only 5 to 15 pixel wide. So that's the reason that it makes it sometimes fainted, especially during those microscopic images that is very blurry and invisible. So this tiny parts of the motors, it makes it very invisible. So that's a section that is just hiding so many times, and especially if it goes next to the boundaries of the imaging, it's not showing. So it's causing lots of problems for the false negatives. The false negatives exactly is the individuals that they have a antibiotic resistance. So the goal is to develop a model that is mixing a balance between the speed of the model, not to make it fast, not to recognize lots of false negatives, and not to make it very slow, to not make efficient for the detecting the parameters and others. So here, the sections, this is a tomogram. The tomogram is the 3D images, microscopic images from the bacteria inside the cell. And as you see here, these are going through the different slices, as we see. So these slices, they have coordinates, and all of them is 2D slices, and the tomogram is the coordinates of X, Y, Z, depth, and height, and width. And in this research, it's about 924 times 1912 pixels. So the process of this image, of this project, is at the beginning is the 3D tomogram, 3D images from the bacteria. And then it goes to the magnifier. So magnifier is the part that it finds with the magnifying, like a model is finding those motors on each slice of tomogram. So tomogram, think about the loaf of bread, and when we are making different slices on that, so these are those slices, and now we wanted to find the motors that's causing infection. So here we saw that motor, the model counts the number of motors, and it's also counting the location, and in general, in addition to that, shape, size, and the texture intensity. So it's very important in this project to recall. So false negative rates to help those individuals with the antibiotic resistance, those bacteria that is missed. That's the most important and goal of this project. Here again, it's about the features for each slices that we talk about, it slices of the tomogram that we're talking about this XYZ, and also the voxel spacing and number of motors. And here is the visualizations of the part in the 3D, that here we see that the number of motors, that the yellow shows that it has a higher concentration of motors, and the purple shows the less concentration, and it's in the space locations. And we see that when we saw the bigger size, that means that more amstogram or higher amstogram or bigger motors and more infection. When it's more infection, so that's the reason that is helping those physicians, those medical specialists, to provide the different dosage for the infection diseases, because it's more concentrations of the motors inside the bacteria that is causing the growth more. So based on that, the dosage will be determined, and also for creating new antibiotics, and also nanoscalar that we talk about it. So here it's the relation between the voxel spacing, the size and the shape of the motors, and also the counts, that how many of those tomogram they have this much big shape or size. That here we see that the majority, like 41%, they have 13, that is almost very small motors, and 13%, they have a 16.8 amstogram. So that's a very big motor. So that's a very small percentage. The majority, they have a smaller motors in our data. Here is a distribution of motors per tomogram, that how it's distributed based on the frequency. So when the data is very imbalanced, because the majority of individuals, they have one motors, the majority of those tomogram. And then for the 2 and 3 and 4 and others, they have almost zero, the frequency. So here is also the heat map and correlations between different features of each slices of tomogram with each other. That it shows that if highly correlated or not correlated, or if it's negative. So these are very important part for the interpretations of the results at the end, that how the number of tomograms and the size and the shapes are playing an important part. And here, the parts of the resolution here, the images that I had is on the left side. So see how blurry it is. It's very invisible. It doesn't show anything. But after pre-processing part, that pre-processing is mostly very, very permanent. It's not like augmentation. Augmentation is only for each epoch. and it can be changed through the training. But yeah, through this pre-processing, we could optimize the resolutions of the images. So left side is just become more visible, and it's more, so that's the reason that the motor can be better detected. Those infection in our cells can be more detectable. So here on the left side, we see that it's a single slice showing motor. But what about others? During the training, there are multiple slices of the tomogram. Think about it, that when we go through the pages of the book, when we look at the one page of the book, and then the book is 3D, book is like a tomogram. And those are the pages of the book. So when we go from one page to another page, the location of the points that we put on one page, it can be different on the locations of the that point in other pages when we are looking through the pages of the book one by one. So this is exactly one. And this is very important for the training part, because the model needs to learn exactly which location it can change from a slice to a slice. Here it's in the very high resolution. Here, as you see, the resolution was very bad, very poor, and not visible. But here,
So are you saying that are you registering those images to each other, those slices to each other? So are you translating them so those red dots are on top of each other? Did those red dots in that previous slide, do they correspond to the same location in 3D space?
yes,
the
yes,
same line?
exactly. Yeah, they go through when I look at it exactly through the annotation part. I saw that in the same tomogram, yes. Then it goes from one slice to another slice. It's just changing.
How do
It's
you
changing.
determine where that red dot goes in each image?
It's about the coordinates on X and Y. So in each slice, the coordinates, I put in the metrics, and then I noticed that X and Y is changing from one to another. So it was at the beginning, it was the one slice that it was already determined that it's at that point. But when it goes further to other slice, that coordinates keep moving. So it was not in the same spot.
Is that because of the 3D structure of it, or is that because of like the speed of capturing it?
I believe it's because of the speed. Because the tomogram, it's just not the same, that it's not silent when you go to it's moving. Yeah, when it's penetrating, it's moving. And this is very important because we wanted to know the depth of the motors. The depth is important for the antibiotics, that what dosage, how deep it went. So when it's when it's dynamic, it keeps changing. That's the reason the location is changed. And this image has a poor visibility, but this was the original. But this one, we see that the image is highly improved because of the histogram equalizations or gamma correction, those parts that we penetrate on our images and makes it more visible. So when it makes it more visible, then the motors can be more identified. So that's the reason the motors can be more visible. Here we see that the predicted part and the ground truth. Again, I did this only on validation data for this part, and I noticed that here I put it very sections. It shows very close to each other. So when they are very close, that means that the accuracy of the model is very nicely here for the validation data. So it's almost intersection over union is very high, so it's just overlapping almost each other.
So a human identified those red squares.
Yes.
And then you put two images of on top of each other,
Yes,
and those red squares that you identified ended up in the same spot.
exactly. So this is how it happened. The data that I had at the beginning, some parts of it, it was labeled by the human, by a specialist. And some parts of the data, it was not labeled at all. So I did two methodology. One is pseudo-labeling and also anti-encoder to label, make the data label and use it as a grand truth. And then from that, I move forward. So it was, and especially I also used the external data. The external data, I used it mostly to give the diversity to the localizations of the motors. As you see that motors, sometimes it was on not really concentrated in different parts because even they have a higher speed and they keep changing. But the point is sometimes they're going exactly to the same areas. So that's the reason I wanted to make it more diverse. And I use the external data. But at the beginning, I use pseudo-labelings and also anti-encoder to make the data consistent, all labeled, and then use the predictor method. So here is at the end, is my predictory analysis at the end. It's found the number of motors in, these are slices, each slices. Some slices, they have different motors. And also the matrices, the location exactly, the which part, coordinates. The point here in this project for me, it was, as I mentioned, it was to have a very high recall. But also, we cannot also ignore the false positives. So that was another part of the project that I incorporate, even for those slices that they have no motors, empty slices. To just not ignore, because when we tell the model that only find the motors, then it has only one class. So it's affecting on the false positives. So I made my training in the way to incorporate, even my preference was mostly false negatives for creating antibiotics. And all of them is going to the matrices, as we all know, and getting the MAP and other matrices to see what is the score of our predictions. Thank you so much for this listening to my presentation, and please let me know if there is any question. Yes, please.
I'm still trying to understand how you three-dimensionalize the tail of the bacteria. So if I'm getting this right, there were several pictures taken of the same bacteria while it was moving, right?
Yes, there is a, think about this is a cell and this is a bacteria. But the point is the bacteria is taking, the picture that is taking is from different angles.
Oh, different angles. Okay.
Yeah, different corners. And those pictures are all 3D.
Yeah, okay.
And the problem is when we say that there is no motor, is because when we're taking a picture from this corner, it may, the motor may go to the boundaries, or it may not be visible, because remember the resolution of those images was very poor. It is all blurry, so it was hidden. So that's the reason it's a no tomogram. And also the point is when we see that there is a, I'm personally thinking about it, that there is a gel that we put the ball inside the gel. When there is a ball inside the gel, it's only one ball. But when we could see the slices of the gel, sometimes we see that different parts of the gel is just shows different sections of the ball, but it's only one ball. So when it says one tomogram, one motor inside the tomogram, just motor is like a ball. It's only one ball, but this ball is going to the different slices of the gel. But the ball that is also moving. That's the difference. It's dynamic.
The cells that you're studying only have one motor, or do they have multiple?
I'm sorry.
The cells that you're studying, do they only have one motor, or do they?
No, they have multiple. Some of the, because the cell, it has a bacteria is going from cell to cell. Some of them, they have 0. Some of them, they have 1. Here in this image, I explain, I show it exactly. Some of them, they have 0. Some of them, they have 1. Some of them, they have more, 0, 4, and even they have 10. But the probabilities of those are very less. So the data here is very imbalanced. That's the reason that we need to make like a balancement between even false negatives and false positives. And the accuracy is not very standard here because of being imbalanced. And that was the reason that also I incorporate the external data to create diversity. Yes.
Going back to the research question, so how does localizing the motors and the tails allow for more precise delivery of antibiotics?
For the antibiotics, right? Then, the problems of the antibiotics is they cannot recognize the false negatives. The false negatives are those bacteria that are missed. That's causing the antibiotic resistance for so many people. And unfortunately, for those individuals with leukemia or chemotherapy and radiation, that they cannot recognize those bacteria. That's why they cannot respond to antibiotics. So that was the important part, to recognize all of those false negatives. So even for those, helping those individuals.
So false negative is when you think there's no bacteria in your tomogram, but there actually is one.
Yes, there is a
And you're
bacteria.
detecting the presence of bacteria by the presence or absence of those flagella, those things on the end, because otherwise a bacteria looks like any other cell. Is that what you're saying?
Exactly. Because there is no bacteria to identify, and that's the reason that our body is making resistant, because it cannot detect it, it cannot stop it. So the point is, we want to stop the progression of motors. This is a motors that is a very difficult part inside our body. It keep moving, see? It's dynamic. And we wanted to stop progressing, and we wanted to fight it back. So in order to fight it back and progressing, we need to detect it. We need to improve our false negatives to find all of those.
So the purpose of the drug is to cut or damage the flagella.
Yes, to stop it. That's the only part. And that's what antibiotic is doing in our body. It just, if it's not stopping, it keeps growing, and it goes to our bloodstream, and unfortunately, it's causing some life-threatening problem.
Is this research being implemented in any pharmaceutical?
Yes. I just developed it because, as I mentioned, that it was related to my previous research for the oncological cancer and research. So that was the reason that this research and also 3D RNA. I'm just focusing on both. 3D RNA is also kind of the same story, different story, but same applications, that how our RNA is getting damaged during different infusion, and how it is causing a deletion or addition on the length of our RNA. So that's causing cancer progression at the beginning and different stages of the cancer. Thank you again. Thanks.
Thank you very much. Appreciate it. That wraps up. Thanks, Faye. That pretty much wraps up our meetup. I do want to thank our speakers. I want to thank Qualcomm for having us, and I want to thank Neo4j for the pizza. You're good to hang out for a little bit, but we should probably be out of here by around 9-ish. Yeah, thanks for coming to the meetup. And if you want to sign up to be a speaker, please do. SanDiegoPython.org. It's the big button. Big button. All right, have a good one. There was an extra HDMI.
Must have been. No, I'll recognize it if it is.
Is that a sticker on?
Hesitant to take it though, in case it's from here.
It's not from here, or rather, it was in the bag.
Okay.
I mean, it was in the bag.
At least it closed.
Oh, you know what? I didn't stop.